Alright, in this video we are going to look at some basic significant figure identification problems. So basically we're just going to go through and look at several different values that we are given and just practice determining the number of significant figures that each of these measurements has. So we will start here with 1a. Now we look at 1a and we see that we have 0.0120 meters. So when we look at this, we recognize first that any zeros at the beginning of a number are insignificant. They do not count as significant digits. However, remember that all non-zero digits are significant, and our number ends with a 0 here, and because the 0 is after the decimal point, it is also considered to be significant. So this particular number has 3 significant figures. Okay, now we look at B. We have 100.5 milliliters. In this, we see 2 zeros here. Remember, all non-zero digits are significant, so the 1 and the 5 are significant. The 1 and the 5 are significant. And also the rule for zeros, one of the rules is that if you have zeros in between non-zero digits, those are also considered significant. So in this particular example, every one of these digits is significant, so we have 4 significant figures. Next we have 101 grams. All non-zero digits are significant, so both ones are significant, and if you have a 0 in between 2 non-zero digits, it is also significant. So again, every number here is significant for 3 significant figures. Next we have 350 square centimeters. Alright, so now we have the 3 and the 5 are non-zero, so they are significant. However, this 0 right here, however, is at the end of a number, and it is to the left of where a decimal point would be. Now, that makes a 0 insignificant unless the decimal point is actually drawn in or written in. And in this case, that is not the case. We have 350, no decimal point written, so that just means that we have 2 significant figures here only, the 3 and the 5. The 0 is not considered a significant figure in that particular problem. Next we have 0.97 kilometers. Remember, zeros at the beginning of a number before all non-zero digits are insignificant, so that is not a significant digit, but all non-zero digits are significant, and so that includes both the 9 and the 7, so we have 2 significant figures. Next we have 1,000 kilograms. Well, 1 is significant. We have a whole number here, though, that ends in 0. In fact, it ends in 3 zeros. Well, because we do not have a decimal point written and we have no other information, we have to assume that all 3 of those zeros are insignificant. So this number, 1,000 kilograms, has only 1 significant figure. Next we have 180 millimeters. Again, the 1 and the 8 are non-zero digits. Those will always be significant. We have a whole number here that ends in 0. This 0 right here is not followed by a written decimal point, so it is considered to not be significant. So this number has 2 significant figures. Now we have 0.4936 liters. This number begins with a 0. Any 0 before non-zero digits is insignificant, but all of these are non-zero digits, so each of those would be considered to be significant. So this number has 4 significant figures. Next, we have 0.020700 seconds. Once again, zeros at the beginning of a number before all non-zero digits are considered to be insignificant. All non-zero numbers are significant, so we have the 2 and the 7, those are significant. And the 0 in between them is also significant because it is between 2 non-zero digits. Now the question with this one here really should be, what about the last 2 zeros here at the end? Well, the rule for zeros at the end of a number is that if it is a whole number, the zeros are insignificant unless there is a decimal point that has been written in. They've made a point to write in the decimal point. The rule is a little different if we are going to the right of the decimal point. So our decimal point is right here, and these two zeros are to the right of that decimal point at the end of the number. When this is the case, those zeros are considered to be significant. The scientist who's giving this measurement, when he writes these zeros here, he or she writes these zeros here, he or she is claiming to have this degree of accuracy, so they actually are considered to be significant. So remember, the first two zeros are not. All remaining digits, however, are significant, so this number would have 5 significant figures. Okay, for number 2, what we are doing is we are rounding to the specified number of significant figures. So here we have 5,487,129 meters. Round that to 3 significant figures. Well, we have all non-zero digits here. So basically we have to take the first 3, 5, 4, 8, and then we look at the fourth number, and that tells us what to do with the, which is 7, that tells us what to do with the 8. So 7 would cause the 8 to round up. So we start off with 5, 4, 9. Now, a very common mistake that I see all the time is that people might stop right there and say the answer is 549. All you have to do is think about this for a second and realize that it would be ridiculous to say that 5,487,129 rounds to 549. So what we have to make sure that we do when we're doing this kind of rounding is that we add in all the remaining zeros here. So we would have, let's see, 1, 2, 3, 4 more zeros here, and that would give us a number of 5,490,000 meters. And make sure that you write the units. If you don't write the units, you will not get full credit, because the units are a very important part of all scientific measurements. Okay, next we have 0.013479,265 milliliters, and that needs to go to 6 significant figures. Okay, well, remember, zeros at the beginning of a number are not significant. All the rest of our numbers here are non-zero digits, so we just count out the first 6. We have 1, 2, 3, 4, 5, 6. Those will be our 6 significant figures. The 6 here will tell us what to do with that 2 at the end. So we would say 0.0, and those are non-significant. And then we have 1, 3, 4, 7, 9, and our last number here is the 2, but it will round up to 3 because it is followed by the 6 there. And that's all that we do right here. We just write in our units milliliters. Now in this case, we do not add zeros because we are to represent or to replace the 6 and the 5, because we are to the right of the decimal point. And if we add zeros to the right of the decimal point, we will be claiming them as significant, and that would be too many significant figures for what we were asked to do. So 0.0134793. Okay, next we have 31947.972 square centimeters to 4 significant figures. So all of these are non-zero digits, and now we just we would get the first 4. So we have 1, 2, 3, 4. Now we're given a number that goes to past the decimal point to the right of the decimal point, but that doesn't matter. We are asked to go to 4 significant figures. So we would start off 3, 1, 9, and now we have 4, but it is followed by a 7, so we would round up. So we have 3, 1, 9, 5, and then we don't stop there, though. That's 3,195, and we have a number that's more than 31,000, almost 32,000, so obviously that does not round to 3,000 something. So make sure we add in a 0 here. Now, even though we have all these numbers here to the right of the decimal point, we have to just accept that we are losing them. Because we're rounding to 4 significant figures, and we've already taken care of that. The 0 here at the end of the number is not significant because we have not written a decimal point at the end. So we have to write in our units as well. We have square centimeters. Okay, next we have 192.6739 square meters. That has to go to 5 significant figures. So again, we have all non-zero digits here, so it's relatively simple. We just take the first 5. 1, 2, 3, 4, 5. That's 192.67, and then after that we have a 3, so that means our 7 is going to remain a 7 and not round up. So we have, we'll write this out, we have 192, and then we have our decimal point, and then it is 0.67, and now we do not add zeros for the 3 and the 9 because those zeros to the right of the decimal point would be significant, and we are asked to not go to that many significant figures. So 192.67 gives us our 5 significant figures, and as always we need to write in our units at the end. Okay, next we have 786.9164 centimeters, and this needs to go to 2 significant figures. So that means we just take our first 2, 7 and 8, and the 8 is followed by a 6, so that tells us that our 8 is going to have to round up. And so we have 7, 9, once again, 786 does not round to 79, so we need to make sure that we put in our 0 for 790, 786. We can accept that that could round to 790, and this number that we've written here has 2 significant figures. We again have to ignore all of these numbers here to the right of the decimal point in our final answer. So we have 790, and the units are centimeters. And next we have 389,277,600 joules, and we need to round this to 6 significant figures. So again, we take our first 6, 3, 8, 9, 2, 7, 7, and pay attention to the next number there that's given is a 6. That will cause the 7 preceding that 6 to round up. So we have 3, 8, 9, 2, 7, and then our second 7 will round up to an 8 because it is preceded or followed by a 6. Now, once again, we have 389,278 so far written, but the number that we're given is 389,277,600. That's not going to round down to 389,000, so we need to add on those final 3 zeros to make sure that we are in the hundreds of millions and not the hundreds of thousands. So we have 389,278,000, 389,278,000 joules. And all those zeros in the end are not significant because it is a whole number and they are not followed by a decimal point. Okay, our last one here, we have 225,834.762 cubic centimeters. This needs to go to 7 significant figures. So we count 1, 2, 3, 4, 5, 6, 7, and that 7 is, our last number 7 there is followed by a 6, which would tell us that the 7 is going to round up. So we have 2, 2, 5, 8, 3, 4 point, and it's 7, but it's going to round up to 8. That number, 225,834.8, is a number that has been rounded to 7 significant figures. We do not add zeros on the end for the 6 and the 2 over here because we are to the right of the decimal point, and if we did so, we would be adding significant figures, and we already have the 7 that are called for. So all we need to add here now are our units, that's cubic centimeters, and that's the final answer there.